Now, we're continuing with organic chemistry. Can I remind you again now, please? You should have 6 pages. That's number 1. To cover these particular videos. If you don't have them now, please, again, I'm telling you, pause the video, go away and print them out so that you have them in front of you. We're presently on page 2 and 3, okay? And we're going to finish that now initially. There isn't much to be done in it, but I just want to remind you here from our plan now. Basically, we're dealing with hydrocarbons, alkanes, alkenes, alkynes. I'll mention briefly aromatic hydrocarbons. We're only dealing with compounds containing carbon and hydrogen only. The rest of organic chemistry is not on for your exam, so don't worry about it. What you must work on here is just this piece here, and I'm going to do 5 and 6 with you today. That happens to be the petroleum industry and petrol itself in octane numbers, okay? So that section there is the bit you want, and that's the bit you must revise and study, and I hope that's okay. Now, where we had finished in the last video was we had gone through alkanes, alkenes, and alkynes. Can I just maybe draw the second member of each of them for you then, okay? Here's ethane. Here's ethene. And here's ethyne. And they're the skeletons, okay? You must put H's in, of course, to get any marks. Very important. Can I remind you now, please? That's the alkane. It's ethane. A-N-E, and everybody knows that's saturated. All the bonds are used up. Yeah. This one here is ethene. Are you okay with that? And that's unsaturated. It has at least one double bond. Okay, it's unsaturated, right? And the last one is ethyne, and it is, of course, ETHYNE, ethyne. Okay, it has a triple bond, and that's unsaturated. Okay, it's saturated when it has all single bonds. Now, think about this for a moment. If this is to react with anything, you'll have to remove a hydrogen to put something else in instead of it. They're called substitution reactions. They're harder to bring about, and consequently, you'll have less actual reactions there. These two, with the double bond and the triple bond, are unsaturated. So when they react with something, they split these bonds. They break open. So you can add straight onto them. And they're called addition reactions. They're much easier to bring about, so they have more properties and more reactions as a result. Now keep that in mind. Later in your course, you have to do a mechanism. That is a scientific explanation as to how substitution and how addition takes place. Okay, and that's very important. We have that done. Now we've got that far, and of course it's very important you realize that you're expected to describe the laboratory preparation for that. We did that in the last video. Make sure you know it. It's mandatory. And right now, I'm going to do the laboratory preparation of ethyne with you. Okay, I'm going to do the laboratory preparation of that, and that's what's coming up next. Now, that's on page 3 of your notes, so you shouldn't have any issues with that. It should be possible for you to work your way through that fine, okay? I'm reminding you again now that everybody needs to be aware of what we're doing here, and that is the page you're working on now, right now, okay? That page you're working on, very good. And that is the preparation of that. I'm going to put it on the screen for you, and we can be investigating it again as we go along. But the preparation of ethyne is the second of these preparations, and there it is there. The one on top is the one we did in the last video. So this one is that. I'm just going to cover that one, so you're going to work with that one only. All right? Now, let me down the light again so you can see it for a moment as to what's happening there. Now, basically, I have the apparatus here as well. I'm going to show it to you, right? You have a flask here with basically a tap funnel on top of it. And you'll put a compound called calcium carbide into this. It looks just like cinders from the fire, like charcoal from the barbecue. It looks a grey, solid, dusty material. Generally speaking, that's what it looks like. And in here, on top here, inside of the tap funnel, you open the tap to drop it in, you put the liquid, it's water. So when the calcium carbide reacts with the water, it produces the gas, and the gas escapes through the side limb here. Okay, that gas, like in the last case, is collected over water. There's the water, there's the calcium carbide. The gas will go up through this pipe, come down in here and be collected over water. Now that's an additional piece I want to talk to you about. Sometimes the examiner will leave this out. The gas is produced here and it's collected here, just like ethene. Ethane is collected in the same way. You can come to the conclusion that they must be similar in some way if they're collected over water. That's right, that they do not dissolve in water. If they dissolved in water, you couldn't use them. That would be the simple reality, and we have to work with that, okay? So ethane is collected here. Now this unit here is called a washing bottle. Some people call it a drational bottle, but don't worry about that, it's a washing bottle. And basically what happens is you connect the pipeline, the supply of the gas is fed through a solution in this flask. Okay, and so there you have, this is the wash bottle. There's a pipe going down the middle. The gas bubbles through that, through the solution here, and back out over on this side where it's collected over water. It's called the washing bottle. This one here is the washing bottle. Are you all okay with that now? That is the apparatus, right? And the gas is collected. Sometimes the examiner will leave out this washing bottle, so please be careful, okay? Sometimes they'll leave it out, and you'll have to realize then that you'll get impure gas. If you just collect this gas now, it may be impure for reasons I'll talk to you about in a moment. But we need to be aware of that, all right? Now, we better get that recorded before we do anything else, and that's what I'm going to do with you. I think we better draw that particular piece of apparatus. Can I remind you again now, please? This is a mandatory experiment. There's an expectation on the examiner's part that you would know the procedure for this, right? Very important now. This is a mandatory experiment. You'll be asked to draw the apparatus used, and here we go. I'm drawing the flask for a start. There's my flask, okay? And I'm going to put a side pipe out there to take that away. That'll be fine. There'll be no problem with that, okay? And you have a little stopper here, and you have a funnel here. Okay, nothing fancy now. You needn't be worried about this at all. But please, could I advise you all to make your diagrams reasonably large? In an exam, if you want to get marks to them, about 1/3 of an A4 page in height is a good judge. Okay, that's an A4 page, about 1/3 of it, okay, and quite a large diagram. And sometimes people just use a line for the pipe, and that's okay. And so you could do that, okay, there you are. There is the gas, and it's collected then over water, okay, that's a trough. That's a beehive, and there's the water, and the gas will bubble through here. It will bubble out here and through there, and that would be C2H2 collected here. The solid here is calcium carbide. Can I remind you of that? It's CaC2, calcium carbide. Okay, I've told you it looks like charcoal. Okay, it's a greyish colour. Okay, and basically when the water reacts with it, it will deliver gas, and the gas will come out here and be collected over water. Now, the gas is going to have impurities in it, which I'll talk to you about separately, and because of that, they put a washing bottle in there. That's a gas washing bottle. I'm stressing again to you now, what you simply do with this is, the gas being produced is put in here, it goes down through the center tube, and then comes out through the stopper. Now, this is a piece of quick fit apparatus, so you don't need to worry about trying to draw that. Keep it simpler. I have a simpler version there. The gas comes in through the long pipe, bubbles through the solution, and goes out there, and then you have pure gas there. Any impurities will dissolve in that solution, which I'll talk to you about in a moment. Now, sometimes that will appear in the exam, and you will be expected to answer what's missing. Okay, or you'll be expected to be aware that that gas is not going to be pure, okay? If you want to purify it, you must put it in the middle. I'm going to do that for you now. In a very simple sense, I'm going to give you a little washing bottle here. Okay, that's all, little washing bottle. Take the pipe, and it goes down into this solution. Okay, it goes down, and it bubbles through this, the gas. And then it comes out through this pipe, and now it's collected over water. Are you okay with that? It's now collected over water. That's very good. And what happens there, of course, this is all water. You know that, don't you? Yeah, and it's going to bubble through here. And there's the gas. Now, that'll be a pure gas now, okay? Because that's the washing bottle. Remember, that limb or that tube must be long, and the other one short, so the gas can get back out. That particular bottle for washing gases is used for lots of preparations where there are gas impurities. You have ethane being produced. Ethane is not soluble in that, but the impurities are. And they tell you in your text, if you go looking for it, that that is acidified copper sulfate. Acidified copper sulfate. Now it's a blue color, don't worry about it, just that's the washing solution. And there are other gas impurities besides the C2H2 that come out of that, and therefore you have to rid yourself of them, and that's rather important. Now I'm going to stay with your notes a second because I'm keen that you can label the diagrams. The diagram now on page 3 of your notes needs to be labeled. I have A, B, C and D there. A, you know, do you? A is water. Yeah, you need to put that into your notes now. A is water. B is down here, that's B. B is calcium carbide. Will you watch how you spell that, please? Calcium carbide, C-A-R-B-I-D-E. Do you remember what I said to you already about compounds ending in I-D-E? There's only 2 elements present, carbon, calcium and carbon. IDE, okay, calcium carbide, okay. This reacts with water, okay, it produces the gas, and the gas comes out through the side pipe, and it's washed here because there are other gases produced as well. All the other gases are going to be dissolved in this solution, okay, and that's very important. Now, C is this particular compound, okay, C, they asked you to name C, acidified copper sulfate. It's copper sulfate with a small amount of sulfuric acid in it. Don't worry about that. If you say acidified copper sulfate, you'll be doing fine. There'll be no issue with that at all, okay, and that's very important. Now, so the gas comes through here and is collected over water. That'll be pure now. It's pure if that is present. It would be impure if it wasn't. Not your problem now, you just have to work with what's in front of you. Now, there is an expectation here that you can write a balanced equation for this reaction. Okay, CaC2 plus H2O is going to give you, it's going to give you calcium hydroxide, okay, and it's going to give you the product C2H2, and there's your product. That's what you're looking for, and that's a balanced equation. Now I'm repeating that for you. There's an expectation that you could write a balanced chemical equation for the preparation of ethine. It's a mandatory experiment, and mandatory always raises the bar. Now, will you keep that in mind, please? Very important. Mandatory experiment, right? So, very important that you can reproduce that. Could you write a balanced equation for the preparation of ethene? It was a little easier, wasn't it? You had ethanol, and it went to ethene, and it emitted water. So it was an easier. This one is slightly more difficult. Now, there's an expectation you can write both of those equations. Now, please attend to that. Sometimes you're thinking they give you this as an illustration. No. In this instance, they're the only 2 mandatory experiments where they have an expectation you could write a balanced equation. And there you go. That's calcium hydroxide. Okay, and that's it. So that's exactly what you do. Now, again, as in the last experiment, you would dispense with the first few test tubes of the gas because it's mainly air. You have to get the air out of the tubes, and so the first one you will dispense with it, and then you start collecting several test tubes of ethine. That would be standard practice. Now, what kind of questions would you be asked here? They'd ask you to draw a diagram of the apparatus used to prepare ethine. Okay, and that means reproducing this. Now, nothing fancy. I'm well aware of this. I would consider myself reasonably okay at that, but as long as it reflects the apparatus, it's fine. Please, a bit of size in it now, please. Okay, give yourself a bit of space and loads of room and label everything. That's a trough. That's water, that's a beehive, and that's a collecting test tube or whatever tube you're using. Okay, it could be a gas jar or whatever. That's simply a washing bottle. A washing bottle, you're washing the gas. The gas has impurities in it, and you must name that. There'd be different reagents here for removing different impurities. So in different experiments, they'd have different reagents in here. You must know it's acidified copper sulfate there to get rid of that. Now, in your notes, I have written down 2 things, and I want to make sure you clarify them. Impurities is at the top of that little table there. Impurities on one side, and there's the source in the other. S-O-U-R-C-E, okay, the source. Now, we're talking, will you write in there, please, gas impurities, okay, gas. It's gas impurities, okay? What gas impurities are removed here, in other words, and where do they come from? Now, if you can name 1 gas impurity, you'll get the marks. Now, let me tell you about this. When you purchase calcium carbide as a solid, it is impure. As well as calcium carbide in it, there are other calcium compounds as well. You'll get traces of calcium sulfide, which is an easy one to use, okay? That's a smelly one. You'll get traces of calcium nitride. I don't want to be going into all of these now. Calcium nitride, valency 2, valency 3. 2 and 3 there, don't worry. But you'll get, along with the calcium carbide, you'll get some calcium sulfide. And look, let me show you now for a moment. If you had calcium carbide here, C2, what you would get here is C2H2. Isn't that right? From the calcium carbide, you get ethyne. So I'm asking you a question. What chemical change has happened there? And the answer is the calcium is replaced with hydrogen. The calcium in the solid is replaced with hydrogen. So if one of the impurities, when you purchase that, if one of the impurities was calcium sulfide, now I should be writing them the other way around, sorry, let me do that for you so there's no confusion. If I had the source of the gas is calcium carbide, and the gas is C2H2. So what's happened? The calcium has been replaced by the hydrogen. So supposing you had traces of calcium sulfide in that, what you get here is, calcium sulfide in that, traces of calcium sulfide, what you get here is H2S. In other words, I swapped the calcium for a hydrogen. That's easy, okay? Now you only need one, and I'm happy for you to stay with that one because it's easy. The valency of calcium is 2, the valency of sulfur is 2, so it is 1 to 1. That's an easy one, okay? But you could also get traces of calcium nitride in there. Calcium nitride in there. And what would you get in that case? You're replacing, in this case, remember, the calcium with hydrogen, so you're going to get NH3 as an impure gas. And I could go on. Okay, I could go on. There's plenty more of them there. We don't need to do it. There's a calcium phosphide as well, and you get phosphine. So they are the impure gases. And that's what's removed there. All of them are soluble in the acidified copper sulfate, but of course the ethyne is not. And that's exactly what the washing bottle is for. The washing bottle removes impure gases, making sure that the gas you produce here is pure ethyne. Now I'm mentioning to you, that could be left out in an exam and you could be asked, how would you purify the gas? Now remember, this is mandatory. I keep reminding you mandatory. It means you're expected to be very familiar with it, all the apparatus and all the chemicals. It's a bit more than your average question, so be careful with that. So in your table there, please, one of the gas impurities, will you write the word gas over impurities and put in this particular case, the impure gas would be hydrogen sulfide. By the way, that's a very dangerous, smelly gas. Hydrogen sulfide, okay? It is hydrogen sulfide, and that's calcium sulfide. And if there was some calcium sulfide stuck inside that, then you replace the calcium with hydrogen, so there's the impure gas. That would be removed by the acidified copper sulfate, right? Same with this one. If you had calcium nitride inside the calcium carbide, traces of it, impurities, when you'd add water to that, you'd replace the calcium with hydrogen, and you'd get ammonia. So ammonia would be the impurity. That would be dissolved there as well. Ammonia dissolves readily in water anyway, but it will dissolve well in that. So the only gas bubbling through here would be the C2H2, and that will give you the result, and that's what you need. Now, I have something written at the bottom of your page there. I just want to tell you, they won't trouble you with that. If you were doing it with me in the lab, I'd be wanting you to try that. That would allow you, that little test would allow you to distinguish between ethene and ethyne, because they both have the same properties, really. They have the saturation properties, which I'm going to deal with. Now, folks, can I get rid of this? Now, please, you need to doodle a bit. You need to take a pad and scribble, okay? You need to draw these a few times to get a sense of where everything is. Do you see how I draw a line for a pipe? I don't bother with 2 lines. That's okay. Okay, make sure the long one comes in here, okay, and the short one is here. That the gas has to come through the solution to get out. Okay, and make sure you're showing the bubbles going up here and you're showing that that is the gas. That's the washing bottle, and you must know this and you must know this. And everybody, please, you must be able to reproduce that equation on top of the board. That's very important now. Okay, if you don't get that right, you lose significant, at least 6 marks for that. At least 6 marks, okay? Very, very important. Don't be surprised if that goes missing, choosing to ignore the fact that the gas is impure, okay? But you remove the impurities with the washing bottle, and that's very important, all right? And we have to deal with that in what we're doing. Now, folks, you're looking at your page again now, properties of ethene and ethyne. I'll get rid of this now, and we'll work on that then. Properties of ethene and ethyne. They're exactly the same properties as you had for ethene in the last video. Okay, and you're going to complete the boxes on the right hand side here now. Mix with bromine. What will happen if you mix with bromine? If you mix with bromine, then the yellow color will disappear again, proving it is unsaturated. The first two tests, 1 and 2, on that page 3 of your notes now, page 3, on the right hand column, ethyne, right? You'll be writing in the first box there, mix with bromine solution, and what's going to happen is the yellow is going to go colorless. Here's what's going to happen. C2H2 plus bromine is going to go to C2H2Br4. Now don't worry about that, other than you're going to use that up. That's yellow, so it's going to go colorless. So you basically take a test tube of ethyne, take the stopper off, put a little bromine solution into it, which is yellow, shake it, and the bromine will disappear. It will go into that. Now I'm showing you what's happening here. You don't need to take this down. This is what's going to happen. It's going to be an addition reaction. When you react the bromine with it, the bromine is going to split those two open and put a bromine there and there. And then it's going to split that open and you're going to get a bromine there and there. Now you don't need to write an equation for that, other than to realize if it's unsaturated, the bromine will get swallowed up by the molecule. You'll have no bromine left, so you'll have no yellow color. Now, are you okay with that? Because that's effectively what you want. If you have that, you're on your way. Good. That's one. That's a test for unsaturation, because the alkynes are unsaturated. Mixing with acidified KMnO4. Same-o, same-o. What will happen is basically when you react with the KMnO4, the KMnO4 will go to Mn2+. That's purple. That's colorless. Okay, and consequently, because the color disappears, then it's unsaturated. That wouldn't happen if you had ethane. That wouldn't happen if you had ethane, because ethane is saturated. Okay, so you need one test for saturation. 1 and 2 there in that list, that little table, are the unsaturated tests to show that ethyne has a triple bond, or to show that ethene has a double bond. They are the same tests. Okay, they're the same tests. Now, burn each gas. Each gas means burn ethene on the left. Yesterday I asked you to fill in there in the previous video. What kind of a flame would you get? They'll ask you to describe it. If it is ethene, it's a clean flame, in other words, smokeless. It will be not very bright, and it will have a blue tint to it. If it was ethyne you were burning, you'd get a smoky flame. Okay, there's a higher percentage of carbon in it, you get a smoky flame. It will give you a bright or luminous flame, a very bright flame, brighter than the ethene now, if you're trying to compare them, and it will be yellow. Okay, now that is, I'm suggesting to you, that happens to be ethyne. What about ethene? I'm going back a moment. It'll be a clean flame, non-smoky. Clean mightn't be great now. Non-smoky flame, okay? Non-smoky. Luminous, less bright. And this color, there'll be a tint of blue in it, I told you yesterday, in this flame, the color of the flame, okay? That's C2H4, that's C2H2. Are you okay with that? That's smoky, that's not smoky. That's bright, that's less bright. That's yellow, and there's a blue tint to that flame. Now that's what they'd ask. You take a test tube of your gas, take the lid off it and burn it, set it alight, and you're going to get the blue flame. And that's, excuse me, that's why you're all at home. Good. Okay, so will you take it, please? That's what we're dealing with more than anything else, and that you have a sense of that. Okay, now that's very good. That's what you want, and that's the main thing. And it asks you to write equations for each. Now, how are you fixed? That's the last thing I'm going to do with you. Writing equations for each now. That's a task now you have to practice regularly. And I don't mean look it up. How much do you know already? If you're working like that, you're going to do very well. And I would suggest that that's what there's one of the equations, right? You will be writing equations for the preparation. Write equations for each. Can you write an equation for the preparation of ethene from yesterday before I finish? C2H5OH. And it goes to C2H4 plus, in this case, are you all right? Can you finish that? Are you all right? Plus H2O. Okay, you take a H out of one side and OH out of the other. Let me show you. There's a H, there's an OH, H, 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 and H. So you eliminate that, you take that out, and you'll end up with a double bond. Now, you're expected to be able to write both of those. Now, don't be under any illusion, there's a catalyst here. And catalysts don't work at low temperature. There's a catalyst there, and you need that. Now, do you think you're okay with that? That's a very important piece of work now. I can't say it enough to you now. They're mandatory. That gives them a higher level of priority. Anything in the mandatory list must get attention from you. The examiner has every right to ask you in Section A of a mandatory list, anything from Section A, but they can also ask that in Section B, because it's mandatory. If they want to establish if you've your course covered, they'll go after anything that's mandatory. Now, you don't need to know any more than I've done, but you need to know all of it. If there's any leaving out to be done, I've done it for you already, okay? So please now be fair about this. You need to work on getting that right, and that's the end of that. Now I'm back again to page 2 for a moment. There's a little bit there in your notes on page 2 that I must finish. There are 3 types of hydrocarbons. I better just wrap this for you now. Let me take that one away again. They're the 2 gases, by the way, before I remove them. Are you all right with them? They are the 2 gases. Are you okay? That was the last video. Are you okay? The preparation of ethene, and there's the preparation of ethyne. Are you okay with them? Both of them are very important, and it would be important that you'd follow them up. Now, the next thing I want to show you is this. We need to look at the unit itself. You must be careful when you're covering something that you cover it all and you cover it well, and that's it. Now look, what are the hydrocarbons on your course? Alkanes. There's no preparation there for you. Alkenes. Alkynes. And now I'm going to spend a moment on aromatic hydrocarbons. Okay, I'm going to spend a few minutes on that to make sure it's okay. It's referred to in your notes. I've set you already on page, it's there on page 2 of your notes. Okay, there's only a little bit on it, and there's only 3 molecules on the syllabus that you would need to know about, and I'm going to deal with them for you now. Okay, I'll get rid of these again. Now, I've just rubbed 2 equations from the board. Could you rewrite them now? Now, it's very important that you're not looking things up. When you look things up, short-term memory takes over, and you have it again for the next 10 minutes, and it's gone again. You must always check first. How much of it do you have already? What bit are you missing? And when you do that, test yourself, and you'll see very quickly that, you won't be remembering words here now, you won't be remembering formula, you'll be remembering detail, and you'll find that that'll work very well for you. Now, there's only the idea of aromatic. In organic chemistry means it contains the benzene ring. This is the benzene ring. 6 carbons in a ring, like that. Double, single, double, single, double, single. And of course, they must all have 4 bonds. They must all have 4 bonds. So just one there like that. Now, H, H, there, right throughout that. They are the compounds you're talking about. That is the benzene ring. And now that's a fairly complex molecule, but can you see it has double bonds in it? And it's very stable. It's very hard to break that ring. Okay, it'll react on the outside rod. It contradicts all the rules you have so far, but that's benzene, and it's often written like that. That's the symbol to represent that, okay? And so consequently, you have a number of molecules you can have on your course. Notice they have only hydrogen and carbon, so they're still hydrocarbons. But they must have that ring if they're to be aromatic. And so benzene is one, methyl benzene is the second one. I'm going to change that now. I don't want to write it 3 times, so will you let me change that for a moment, okay? Methyl benzene means there's a methyl group here, CH3. Okay, that's all carbons and hydrogens as well. If you wanted to write that like that, you could do it. H, H, and H, that'll be fine. Okay, that's methyl benzene. Okay, that's the methyl group, and it's replaced one of the hydrogens. That would be written like this, by the way. There's the benzene ring, okay, and you could put CH3 there if you wanted. CH3 would be nice. There, like that, okay? That's methyl benzene, okay? And the last one is called ethyl benzene, where the methyl is replaced by the ethyl group. Eth meaning 2 carbons, C2H5. There's a carbon, there's a hydrogen missing to attach to the other carbon there, of course, and the symbol for that would be this one. Okay, same benzene ring again, but you'd have C2H5 there. C2H5 there. Okay, ethyl benzene, methyl benzene, and benzene itself. Are you okay? That ring remains intact. Very, very important you would do that. Now, I suppose I better mention something to you. That could be written in a variety of ways, but just be alert to that, okay? And of course, they could be very awkward with you. They could give you the formula. This is C6H6. C6H6 is just 6 carbons, 6 hydrogens. If you replace that with CH3, you'd have C7H8. Am I right? It is. If there's a H missing, that's right, C7H8. And this one then, you're replacing the H here with C2H6. It would be C8, and it would be H. You have 5 there and 5 there, H10. Okay, H10. There's 5 there, and 5 there is 10. 10, okay? Now, it would be very mean if they gave you that. But they could ask you, name the aromatic compound C7H8. They could ask you, name the aromatic compound C7H8, meaning aromatic tells you it's a benzene ring. What do you do immediately? Take the benzene ring out of it. C6H5, that's C6H6 with a H missing. C6H6 with a H missing, okay? And so take that away from it, and what do you get? You get CH3. CH3, very good. So you draw your ring and put that under it, okay? And that's exactly what you'd want. Now, please, the information will be in the question. I just need you to have heard of these. I'm not making a big deal of them. But they are, if you're to complete the story on hydrocarbons, that's the fourth and final category. Probably the least important, but they could come up in the exam because they're hydrocarbons. I'll ask you now to be careful with that, please, whatever else you're going to do. These are aromatic hydrocarbons, and they're the only 3. The name is benzene, methyl benzene, and ethyl benzene. And I'm mentioning to you, this one happens to have a commercial name called toluene. Now, if you're taking your chemistry studies any further, you may eventually come across a compound called TNT. It's an explosive. Trinitro-toluene. There'll be 3 nitros in there. It's a very unstable molecule. Okay? But toluene is the commercial name. The chemical name would be methyl benzene. Right? And that's effectively what you need. Now, that brings us to the end of that category. Okay? We have that complete now there, number 4 and that, okay? And that's the first 3 pages of your notes. Right? Now, revise them and study them, and you'll have everything you need at the moment. In your next videos, we'll be looking at the petrochemical industry, all right?